Okay, we're ready to start Chapter 10, Rational Equations and Applications. So this section is 10.1 on rational equations. So the key with rational equations is we have to find those excluded values. So remember, rational expressions, they're undefined when the denominator is equal to 0. So when we solve a rational expression, the solution is any value we find except those excluded values. And so those are extraneous values, as we call them, and they're not part of the solution. So steps for solving a rational equation is we're going to first determine what the excluded values are for the equation. Then we're going to clear the denominators by multiplying each term by the LCD. Then we're going to solve the equation that's left over. Then we're going to verify the solutions obtained are not any excluded values. And if there are excluded values in our solutions, we drop that as part of the solution, and everything else is what's in the solution. So let's start with this one. And basically what we're doing is we're solving and then we'll verify all solutions, or basically make sure there's no excluded values. So what is the excluded value? Well, it's the point where the denominator is equal to 0. So if we put x minus 4 equal to 0, that means x is equal to 4. So in our final solution, x cannot equal 4. So that is the key here. We can't have x equal 4 or we get a denominator of 0. And so anything else we get is okay, but we can't have 4. All right, so what we're going to do is multiply by the LCD, which is just x minus 4. So we're going to take basically each term times x minus 4. So we're going to do it here, and here, and here, and here. Okay, so when we take x times that, we're going to have x squared minus 4x, and we're just taking x times x, and then x times the minus 4. And now when we take the 20 over x minus 4 times x minus 4, the x minus 4's cancel, and we just get plus 20. Now that equals, now here the x minus 4's cancel again, and we just get 5x. And then we multiply here, and again we're taking a minus 2 times each of those, so we'll have a minus 2x and then plus 8. All right, so when we solve equations like this, now we have a quadratic, and so what we have to do is we have to get everything over to the left side. Well, 5x minus 2x is 3x, so if we subtract 3x here and subtract 3x here, that is what this part will be. Then we're going to subtract 8, and we're going to subtract 8, and so that gives us 0 on the right, and on the left we get x squared minus 7x plus 12. Now, can we factor the left side? Well, that's going to be x and x, and it's going to be minus and minus. Two factors that multiply to 12 but add to 7 are going to be 3 and 4. So now we use the zero product rule. We set each of the factors equal to 0. So we get x minus 3 equals 0, and x minus 4 equals 0. So here we get x equals 4. Here we get x equals 3. But we said at the beginning an excluded value is x equals 4. So this one doesn't work. And so this is going to be our only solution. Okay, so the key is we had to make sure we knew that we couldn't use 4. And so when we said, oh, here x is equal to 4, we had to throw that one out. And then the only solution we got then was x equals 3. All right, let's try this one. Here it's a little more complex. Here we have two things in the denominator. So our LCD is going to be two factors. And what we have to do is find the excluded values. So 3x minus 4 equals 0. And 6x minus 1 equals 0. So here x is equal to, and if we add 1 here, that's going to be 1 divided by 6. So here we cannot have x equal to 6. And here we're going to take and add 4 over here and divide by 3, and so x cannot equal 4. So these are the two values we can't have in our solution. Okay, so what we do now is we multiply, and we have to multiply by both of the denominators, because this is going to be one term, this is the other term, and here we already have that one only one time. So each of them is a factor of one of those. So 3x minus 4 times 6x minus 1. So now we're going to take this times each term here. Well, when we take it times the first term here, the 3x minus 4's cancel. And so we're going to have 2x times 6x minus 1. Now when we take this term times that, the 6x minus 1's cancel, and so we'll have 4x plus 5 times 3x minus 4. And then we'll have minus 3 times, well here the 3x minus 4's cancel, and we have 6x minus 1. So now what we have to do is we have to distribute everything, get all on one side, and then do kind of like we did last time. So here we have 2x times 6x, that's going to give us 12x squared. Then we'll have minus 2x equals, now here we'll have 12x squared. Then we'll have here, we'll just write it all out, minus 16x, and then we'll have here plus 15x. Here we'll have minus 20. Here we'll have minus 18x, and here we'll have plus 3, okay? Now I notice if I take and subtract 12x squared here and 12x squared here, those just cancel. So we can get rid of those. Now what we can do then is we can add 2x, and we can add 2x. So that then gives us the following. On the left is 0. And on the right, we have a minus 16x plus 15x, so that's a minus 1x. And then we have a minus 18 more, so that's going to be a minus 19. Plus 2 is going to be a minus 17x. And here we have a minus 20 plus 3, so that's going to be minus 17. Now this one is a unique one because when we got rid of the x squared, we actually don't have to factor. All we have to do is we have to take that 17 to the other side. And so then we have 17 equals a minus 17x. We divide by a negative 17. And so x equals a negative 1. Now, that's not 4/3 and that's not equal to 1/6. So this is the only solution. We don't have to cancel anything out. And so that would be what that is equal to. Now, if you pulled out your calculator, you could actually plug it in here and verify that the left side was going to equal the right side. All right, what about this one? Well, first we have to find the excluded values. So 1 minus x equals 0 and 3 minus x equals 0. So here I'm going to take the x to the other side, so x equals 3. So we know we can't have 3 as a solution. Here we take x to the other side, we get 1. And so we can't have 1 as the solution. So those are my two excluded values. Now this one, I remember my cross product rule. And if I take the cross product, basically that's going to get rid of my denominators. And it would be the same thing as if we multiplied by 1 minus x and 3 minus x. But I'm just going to do the cross product. So what that gives me is 4 minus x times 3 minus x equals 1 minus x times 12. Okay, now I can distribute. So 4 times 3 is 12. Then I'll have a minus 4x. Then I'll have a minus 3x. And then I'll have a minus x. That's going to be plus x squared. And that equals, and here I have a 12. And then I'll have minus 12x. Okay. Now I think the x squared being on this side being positive is the direction I'm going to go. So I'm going to subtract 12 and add 12x. Then I'm going to subtract 12 and add 12x. So those cancel, and I get 0 here. Now if I rewrite this in descending order as I add things together, I know x squared comes first. Then I have a minus 4, minus 3, so that's a minus 7x plus 12x. So it's going to be a plus 5x. And here, 12 minus 12 is 0, so I just have x squared plus 5x. Well, I can factor that into x and x plus 5 because all I can do is factor out that x here. So multiply that back out is x squared plus 5x equals 0. So I set each term equal to 0. And then here I get x equals a negative 5. So I have minus 5 and 0. Well, we said it couldn't be 1 or 3. And so that means both x equals 0 and x equals a negative 5 will work for this equation. And again, the best check is if you ever want to make sure that those are both solutions, you plug them back into your calculator and verify that those do come out the same. All right, what do we have here? Well, I notice I have a difference of squares here. And what does that mean? That's going to be x plus 2, x minus 2 when I factor it. Then I notice I have an x plus 2 here, so that's one of the terms. And I notice I have something funny here. It kind of looks like that, but backwards. So what I'm going to do is I'm going to take out a negative 1 and then rewrite it as x minus 2. So if I multiply that out, that's a minus x plus 2, which is what that is. And now I really have a minus, so this is, I can rewrite then as 1 over x plus 2, then that's going to give me plus 1 over x minus 2, and then that equals 3x plus 8 over x plus 2, x minus 2 in the factored form. So now I have all the things I need, and I can find my excluded value. So x plus 2 equals 0, and x minus 2 equals 0. So basically, x cannot equal a negative 2, and x cannot equal a positive 2. So those are my excluded values that I cannot have. So what I need to do is multiply everything by my LCD. Well, my LCD is just x plus 2 times x minus 2. And so when I multiply that times the first term, the x plus 2's cancel, and I get 1 times x minus 2, which is just x minus 2. Now here I have x minus 2 times this, and I cancel, and I just get plus x plus 2. And here everything cancels, and I get 3x plus 8. All right, so now what does that go? Well, the minus 2 and a plus 2 there, guess what? Those cancel. And so what I can do then is I can say, well, x plus x is 2x. So I could subtract 2x and subtract 2x. And when that does is gives me 0 equals x plus 8. Or if I subtract 8, x equals a negative 8. And so that would be my solution. And it works because I know I can't have minus 2 or positive 2. And I ended up with a negative 8. So that should be fine. All right, what about this one? Here I have 2x plus 1. Here I have 1 minus 2x. Kind of looks like the opposite of that. So I'll probably take out a negative 1 and switch it around. And here I notice I have a difference of squares. So that's 2x plus 1, 2x minus 1. And if you check, that's 4x squared. Then I have minus 2x plus 2x, so that's 0, minus 1. So that gives me that. So that does tell me that, yes, I need to factor out a negative 1 and have 2x minus 1 here. Now, if I rewrite this then, that gives me 3 over 2x plus 1. And then at minus 1, I'm just going to change that to a negative. And I'll have 2x plus 1 over 2x minus 1. And that equals 1 minus. Then I have 8x squared over 2x plus 1, 2x minus 1. Okay, now what can I have? Well, 2x plus 1 equals 0, and 2x minus 1 equals 0. So here I have x is equal to a minus 1/2, and here I have x equals a positive 1/2. So those are two values that I cannot have in my thing. So those are the excluded values. It can't equal negative 1/2, and it can equal positive 1/2. Now I have my equation set up, so what I can do is I can multiply by the LCD, which happens to be the 2x plus 1 times 2x minus 1. Okay, so when I take that times the first term, my 2x plus 1's cancel, and I have 3 times 2x minus 1. And then I have minus 2x plus 1 times, well here the 2x minus 1's cancel, so I have 2x plus 1 times 2x plus 1. And that equals, now when I take that times that, well then I just get 2x plus 1 times 2x minus 1 minus, now this all cancels that, and I just have minus 8x squared. Okay. Now I just have to FOIL and distribute and then get everything to one side, and I can solve this equation. So here I have 6x minus 3 minus, now I'm going to go ahead and FOIL this all out first, and then I'll go ahead and after that distribute the negative. So 2x times 2x is 4x squared, and I have 2x plus 2x is plus 4x, and then I have plus 1. and that equals, now this is just that, so I have 4x squared minus 1, and then I have minus 8x squared. Okay. So simplifying on each side, I have a 6x minus 3 minus 4x squared minus 4x minus 1 equals, now I have 4x squared minus 8x squared, so it's a minus 4x squared, and then minus 1. All right. So what do we want to do? Well, let's take everything to the left maybe. Although I'm noticing once I take that to the left, plus 4x squared plus 4x squared, those cancel. And so what I think I want to do is I want to have numbers on one side and the variables on the other, because I just have things in relation to x. So if I have a minus 3 minus 1, that's a minus 4. So if I add 4 to that side and add 4 to that side, then I can simplify with x's on one side and the constant, or the numbers on the right. So I have 6x minus 4x, that's 2x. And I have 4 minus 1, well, that's 3. So that looks like that's everything there. So then x is equal to 3 halves. Well, 3 halves is fine because I said I couldn't have a negative 1/2 or a positive 1/2, but it didn't say anything about 3 halves. And so this answer is the final answer. I didn't have to worry about anything that was excluded. All right, let's do one last one here, then I'll make another video with some extra problems as well. All right, so here I see I have an x plus 2, an x plus 5, and this one I see there's a common term in my denominator. So if I pull out a 6, that gives me x plus 4, okay? And so I have all of those. So I have x plus 2 equals 0, x plus 5 equals 0. And I could set that whole thing equal to 0, or I can just set this equal to 0. And in either case, I'm going to get the same thing. So I'm just going to set the x plus 4 equal to 0, because what happens when I have, if I set that equal to 0, I divide by 6, so then I get x plus 4 equals 0 anyway. And so that would be all I need. So here, x cannot equal 2, x cannot equal negative 5, and I should be actually a negative 2. I don't know why I didn't write that. And here, x cannot equal a negative 4. Okay, so I just took those all to the other side, and so I put those cannot equal, because those are my excluded values based on the denominators here. Now, I have 3 factors for my LCD. So basically, I'm going to have to multiply by x plus 2, x plus 5, and then 6. And if I want, I could go ahead and just put 6x plus 24, because that really didn't help me at all. I was just checking to make sure one of those weren't my same term as here. And so those are the 3 things I'm going to multiply by. So I'm going to multiply that by each term. So I'm going to have 3 times. Now the x plus 2's cancel, so I have x plus 5 and 6x plus 24. Plus, now I have x minus 1 times. Now the x plus 5 cancels, so I have x plus 2 and 6x plus 24. And then that equals, and now the 6x plus 24 is gone, and I have 5x plus 20 times, and then I have x plus 2, x plus 5, okay? So these have a little bit more complicated items here, so let's go ahead and multiply. Maybe I could take and distribute this first, or maybe not. I don't know which way is going to be the easiest here. But let's take and say, well, that's 3x plus 15. And then I'm going to take that times this. So I have a 3x times a 6x. And so that's going to give me 18x squared. Then I'll have a 3x times 24. So that'll give me plus 72x. And then I'll have 15 times 6x is 90x. Then I'll have 15 times 24. That's going to give me a plus 360. Now I have plus. Now I've got this one to work with. Well, maybe I can multiply these two together first before I multiply by the 6x plus 24. So when I do that, that's going to be x squared. Then I'll have plus 2x minus x. So that's going to be plus x, then minus 2. And so I'll distribute that with that. So I'll take 6x times each of those first. And so 6x times x squared is going to be 6x cubed plus 6x squared. And then I have a minus times that. And so that's going to be minus 12x. And then I take a plus 24 times all that. So that'll be plus 24x squared plus 24x minus 48. And that equals, all right, so now I have 5x times all this. Well, maybe I'll multiply this one out first. So that's x squared plus 7x plus 10, because it's going to be 2x plus 5x is 7. 2 times 5 is 10. And so I'll take a 5x times each of those, and then I'll take a 20 times each of those. So 5x times x squared is going to be a 5x cubed. Then I'll have 5 times 7 is going to be plus 35x squared. And then plus 50x. And then I'll have plus 20x squared. And then plus 140x plus, and then we'll have 200. All right. So now what we need to do is start simplifying. So here we have on the left a 6x cubed, and so I'll have a 6x cubed. Then I have 18x squared plus 6x squared, and then plus 24x squared. And so that's going to give me 48x squared. And so then, let's see, I better underline these. I got 72, a 90, a negative 12, 24. So I've got 72 plus the 90, then minus the 12, and then plus the 24. So that's going to be 174x. And then I've got 360. And then over here, I've got minus 48. So that's going to give me 312. And I think that's everything on the left. So now how about the right? Well, I've got a 5x cubed. And then I got 35 plus 20x squared. So that's going to be plus a 55x squared. And then I've got, let's see, a 50x, and that's going to be plus 190x. And then plus 200. Oops, not more than that. Let me erase that. All right, so now I think I'll just take everything to the left side. So I'm going to subtract 5x cubed minus 55x squared minus 190x minus 200. And I'll do the same thing here, minus 5x cubed minus 55x squared minus 190x and minus 200. And so that gives me x cubed, and then I have 55 minus the 48, so it's going to be a minus 7x squared. And then I have 190 minus 174, so that's going to give me 16x, and that's going to be plus 112 equals a 0. All right. So now I've got that complicated thing to factor. And so let's see here. I think what I'm going to do here is I'm going to do a synthetic division to try to get me to be able to factor this easier. So I'm going to say, well, let's try factors of 112 and also something that might be 16. So I'm going to try one of my numbers up here. I'm going to try -4. I don't know why that, but we'll try it. And so we have a 1, a -7, -16, and 1, 1, 2. So we bring down our 1, and that's going to give us -4. That gives us a -11. That gives us a plus 44. Then we subtract that. That's going to give us 28. That 4 times that looks like it's going to be a -1, 1, 2. So it's 0. So we have one of our factors is going to be the -4 there. And then we're left with x squared minus 11x plus 28 equals 0. And so that's going to be x minus 7, x minus 4 equals 0. And so that gives us then our terms. And so here, x equals 7. Here we have x equals a 4. And here we had x equals a minus 4. And we know that the minus 4 doesn't work. And so our solution then is x equals 7 and x equals a positive 4. So those are my two solutions. And again, if you plug both of those into your equation, you should get that the left side is equal to the right side for both x equals 7 and x equals 4. So that's going to be the first part of the video. I'll make another part here in a little bit.